Welcome to dividing powers with the same base and also raising a quotient to a power. So here we're looking at dividing powers with the same base. So the rule tells us that if we have the same base being divided, we can subtract the powers to get a more simplified expression. So we've got a to the m over a to the n equals a to the m minus n. So if we look at this in action here, 3 to the 7th divided by 3 to the 3rd equals 3 to the 7 minus 3, or 3 to the 4th power. And again, in class, we'll do a lot with when in doubt, write it out, and we'll see how we can factor out powers of 3 and such. So anytime we have a quotient to a power, and remember quotient is just a division problem, okay? With a quotient to a power, we technically distribute that power to both the numerator and the denominator. And so if we look at our example here, 4/5 to the 3rd becomes 4 to the 3rd over 5 to the 3rd, and then we can simplify that to 64 over 125. So now we're looking at p to the 3rd times j to the -4 over p to the -3rd times j to the 6th. And there's several different approaches to this problem we can take. The one I'm going to do right now is we are going to subtract. So we have p to the 3rd over p to the -3rd. So we have p to the 3rd minus -3, which technically becomes plus a positive. And so we are then left with p to the 6th, and then times j to the -4th minus 6, because again, we have that division there, which becomes j to the -10. However, again, we don't like to leave things with our negative exponents, so then we drop that j to the -10 down, and we're left with p to the 6th over j to the 10th. Okay? In our next example, we've got a real-world situation here, okay? And we've got a dog's heartbeat, which is 64 million beats, all right? And then there are 530,000 minutes in a year. So what is the dog's average heart rate in beats per minute? Okay, so we're going to divide here. So notice how I've set up 64, and then the million is 10 to the 6th, and then we're dividing that by 530,000, again, 10 to the 3rd minutes. So if we set that up, we use our rule, again, to subtract, okay, and we get 10 to the 6 minus 3, which is 10 to the 3rd, okay, which is right there. And then 64 divided by 530 becomes 0.121. So we have 0.121 times 10 to the 3rd. Now we know this isn't proper scientific notation, so we need to rewrite that as with one number in front of the decimal there. So we get 1.1 times 10 to the 2nd. We have to subtract a power there, and we'll talk about that in class again. So now we're raising a quotient to a power, okay? And in this example, we've got 3 over y to the 3rd, and we're going to distribute that 4 to the 3, and so we end up getting 3 to the 4th, okay? And then in our denominator, we have y to the 3rd to the 4th, and so we have to multiply. We use that multiplication rule there, and we get y to the 12th. And then we can simplify that just a little bit more, and we get 3 to the 4th is 81 over y to the 12th. In our last example here, we are looking at 2/3 to the -3rd power. So the first thing I want to do, and again, there's a couple of different approaches we can take to this problem, but our first example here, we're going to distribute that -3, okay, to our numerator and our denominator. That then becomes, because we've got those negative exponents, the 3 to the -3rd actually comes up to the numerator and becomes now a positive power of 3, and then the 2 to the -3rd comes down and loses its negative exponent as well. And then we can simplify that some more to 27 over 8, because 3 to the 3rd is 27, and 2 to the 3rd is 8. All right, in our next example, we've got 4, okay? We've got 4b and that's a negative 4b. It's kind of hard to see that negative out in front there. That's why I encourage you not to write your negative signs in front of your fractions. So notice how I've moved that negative to be with the 4 there, okay? And I've got negative 4 to the negative second power, and then b to the negative second power, and then c to the negative second power. Again, I've distributed that negative 2 to every piece of the numerator and the denominator. Okay, so now that we've got that negative 4 to the negative second, b to the negative second, and over c to the negative second, remember with our negative exponents, they're going to change the location of that in the fraction. So what we're going to do here is I'm going to bring that c to the negative second into the numerator, and that becomes a plus now, right? And then over negative 4 to the second, b to the second. Okay, and then I'm going to simplify that down just a tad more, and I get c squared over 16, because a negative times a negative is a positive, 16b squared there. And so now we've kind of have our simplified expression.